Hey, you know the basic topic model, which is called PLSA, and now you know how to train it. Now, what are some other topic models in this world? What are some other applications that we can solve with the topic modeling? I want to start with a nice application. It is about Diary of Martha Ballard. So this is a big diary. She was writing for 27 years. This is why it's rather complicated for people to read this diary and to analyze this. So some other people decided to apply topic modeling to this and see what are the topics revealed in this diary. These are some examples of the topics, and you can see just the top most probable words. So you remember you have your phi matrix, which stand for probabilities of words and topics. And this is exactly those words with the highest probabilities. And actually you can see that the topics are rather intuitively interpretable. So there is something about gardens and potatoes and work in these gardens. There is something about shopping, like sugar or flour or something else. So you can look through these top words and you can name the topics. And that's nice. What's nicer, you can look into how these topics change over time. So, for example, the gardening topic is very popular during summer in her diary and is not very popular during winter. And it makes perfect sense, right? Another topic, which is about emotions, has some high probabilities during those periods of her life when she has some emotional events. For example, one moment of high probability there corresponds to the moment when she got her husband into prison and somebody else died and something else happened. So the historians can say that, okay, this is interpretable. We understand why this topic has high probability there. Now, to feel flexible and to apply your topics in many applications, we need to do a little bit more math. So first, this is the model called latent Dirichlet allocation, and I guess this is the most popular topic model ever. So it was proposed in 2003 by David Blay, and actually any paper about topic models now cites this work. But you know, this is not very different from PLSA model. So everything that it says is that, okay, we will still have phi and theta perimeters, but we are going to have Dirichlet priors for them. So Dirichlet distribution has rather ugly form, and you do not need to memorize this, you can just always Google it. But important thing here is that we say that our perimeters are not just fixed values, they have some distribution. That's why as the output of our model, we are also going to have some distribution over perimeters. So not just two matrices of values, but distribution over them. And this will be called posterior distribution, and it will be also Dirichlet, but with some other hyperparameters. In other course of our specialization devoted to Bayesian methods, you could learn about lots of ways how to estimate this model and how to train it. So here I just name a few ways. One way would be variational Bayes, another way would be Gibbs sampling. All of them have lots of complicated math, so we are not going to these details right now. Instead, I'm going just to show you what is the main path for developing new topic models. So usually people use probabilistic graphical models and Bayesian inference to provide new topic models. They say, okay, we will have more perimeters, we will have more priors, they will be connected this and that way. So people draw these nice pictures about what happens in the models. And again, let us not go into the math details, but instead let us look how these models can be applied. Well, one extension of LDA model would be hierarchical topic model. So you can imagine that you want your topics to build some hierarchy. For example, the topic about speech recognition would be a subtopic for the topic about algorithms. And you see that the root topic has some very general lexis. And this is actually not surprising. So unfortunately, general lexis is always something that we see with high probabilities, especially for root topics. And in some models, you can try to distill your topics and to say, well, maybe we should have some separate topics about these stop words, and we do not want to see them in our main topics. So you can also play with that. Now, another important extension of topic models is dynamic topic models. So these are models that say that topics can evolve over time. So you have some keywords for the topic in one year and they change for the other year. Or you can see how the probability of the topics changes. For example, you have some news flow and you know that some topic about bank-related stuff is super popular in this month, but not that popular later. Okay? One more extension, multilingual topic models. So topic is something that is not really dependent on the language because, well, mathematics exists everywhere, right? So we can just express it with different terms in English, in Italian, in Russian, and in any other language. And this model captures this intuition. So we have some topics that are just the same for every language, but they are expressed with different terms. You usually train this model on parallel data. So you have 2 Wikipedia articles for the same topic, or let's better say for the same particular, concept. And you know that the topics of these articles should be similar, but expressed with different terms, and that's okay. So we have covered some extensions of topic models, and believe me, there are much more in the literature. So one natural question that you might have now is whether there is a way to combine all those requirements into one topic model. And there might be different approaches here, and one approach which we develop here in our NLP lab is called additive regularization for topic models. The idea is super simple. So we had some likelihood for PLSA model. Now let us have some additional regularizers. Let us add them to the likelihood with some coefficients. So all we need is to formalize our requirements with some regularizers and then tune those tau coefficients to say that, for example, we need better hierarchy rather than better dynamics in the model. So just to provide one example of how those regularizers can look like, we can imagine that we need different topics in our model. So it would be great to have as different topics as possible. To do this, we can try to maximize the negative pairwise correlations between the topics. So this is exactly what is written down in the bottom formula. You have your pairs of topics and you try to make them as different as possible. Now, how can you train this model? Well, you still can use EM algorithm. So the E step holds the same, exactly the same as it was for PLSA topic model. The M step changes, but very slightly. So the only thing that is new here is green. This is the derivatives of the regularizers for your perimeters. So you need to add these terms here to get maximum likelihood estimations for the parameters for the M step. And this is pretty straightforward. So you just formalized your criteria, you took the derivatives, and you could build it into your model. Now, I will just show you one more example for this. So in many applications, we need to model not only words in the texts, but some additional modalities. What I mean is some metadata, some users, maybe authors of the papers, timestamps, and categories, and many other things that can go with the documents, but that are not just words. Can we build somehow them into our model? We can actually use absolutely the same intuition. So let us just, instead of one likelihood, have some weighted likelihoods. So let us have a likelihood for every modality, and let us weight them with some modality coefficients. Now, what do we have for every modality? Actually, we have different vocabularies. So we treat the tokens of, let's say, author's modality as a separate vocabulary. So every topic will be now not only the distribution over words, but the distribution over authors as well. Or if we have 5 modalities, every topic will be represented by 5 distinct distributions. One cool thing about multimodal topic models is that you represent any entities in this hidden space of topics. So this is a way somehow to unify all the information in your model. For example, you can find what are the most probable topics for words and what are the most probable topics for timestamps, let's say. And then you can compare some timestamps and words and say what are the most similar words for this day. And this is the example that does exactly this. So we had a Coursera that has some timestamps for the documents, and we model the topics both for words and for timestamps, and we get to know that the closest words for the timestamp, which corresponds to the Oscars date, would be Oscar, Birdman, and some other words that are really related to this date. So once again, this is a way to embed all your different modalities into one space and somehow find a way to build similarities between them. Okay, now what would be your actions if you want to build your topic models? Well, probably you need some libraries. So Big IRCM library is the implementation of the last approach that I mentioned. Gensim and Mallet implement online LDA topic model. Gensim is built for Python and Mallet is built for Java. And WordleWebit is the implementation of the same online LDA topic model, but it is known to be super fast, so maybe it's also a good idea to check it out. Now, finally, just a few words about visualization of topic models. So, you navigate through large collections and it is not so easy to represent the output of your model, those probability distributions, in such a way that people can understand that. So this is an example how to visualize phi metrics. We have words by topics metrics here, and you can see that we group those words that correspond to every certain topic together, so that we can see that this, let's say, blue topic is about these terms and another one is about social networks and so on. But actually the visualization of topic models is the whole world. So this website contains 380 ways to visualize your topic models. So I want to end this video and ask you to just explore them maybe for a few moments, and you will get to know that topic models can build very different and colorful representations of your data.